Hello everyone, welcome back. So in this video, we are going to understand another question that we have is find maximum number of fruits collected. The question is saying that we have a game dungeon comprised of n cross m room arranged in a grid. So let's first understand the game dungeon and we'll understand further the description. So this is screenshot of a game where if you aware with this type of game contains a type of grid, you can say, where there are multiple as a player are moving, right? You can have to form, you can go in all the direction, as you can see as a grid, right? You can go anywhere, right? And you can form these things. Okay, so it's a kind of grid. So this is called dungeon. Okay, so let's understand what the question is saying. Okay, further, so the game is a dungeon, and there is another question also we have that I will cover in another video. Okay, let me show you. So this is another question based on the dungeon game, right? I'll try to cover in the next video this question, right? So where you can see player are moving from here to here to here like that, right? And in a grid he is moving. Okay, I'll try to cover this problem because it's also a very important question. Okay, so let's go back to the our question. Okay, our question is, what our question is saying that, so further in the question it is saying that you are given a 2D array that is called fruits. Okay, and its size is n cross n. Okay, so we have given a fruit and it's a type of grid. Okay, where the cell of every grid represents the number of fruits in the room Ij. Okay, so if there is a room that is called Ij, it's a cell, right? If there is a room, right, in the room Ij, these fruit at Ij represent the number of fruit in the room, and each cell is nothing but a room, right? And it contains number of fruit in that room. Understand? Means this fruit cell contains the number of fruits in a room, and room is I and j. Means the cell value is I and j. Let's suppose 0 0 1 1 0 2, like that we have. So those are the room, but that value we have here is contains the number of fruits. I hope you understand. Okay, now understand, three children will play in the game, right? And that is called dozen, right? Three children is going to play the game with the initial position at corner rooms. Let's suppose 0 0, that is the initial corner, right? And then 0 n minus 1 and n minus 1 0, three corner everybody has chosen. Okay, the children will make exactly n minus 1 move, right? And moves according to the following rules to reach to the n minus 1 room. Further it is saying the children starting from 0 0, right? So first of all, let me tell you how. So can we say that if we have a grid like this, okay, if we have a grid and if we will represent in 3 cross 3 matrix, okay, if n equal to 3, I can say 3 cross 3 is our matrix, means total 9 cells are there, right? So very first it is saying in the initial position three children will play in the game that is called corner 0 0 and this. Okay, so very first if we talk about the positions, right, what are the positions we have? If this is your, let's suppose I, right, this is your j, either you can cross it I say. Okay, so if I'll take this 0, right, let's suppose we'll call it 0 0, can we say that if it is 0 0, so this is the first children is standing here. Okay, very first children is there. Then what is the 0 n minus 1? Means if it is 0, the row is 0, n minus 1 means this, it is talking about this one. N minus 1 means what? 3 minus 1 is equal to what? 2. This is 1 and this is 2 if it is 0, right? So this is the corner it is saying, means 0 and 2. So another children is standing here, right? Then it is saying n minus 1 and 0. So if you take 0, 1, 2, what is the another corner? This is your last corner, right? So you can take this corner, n minus 1. Okay, we can take 2 and 0, and here we have another children standing there. Okay, so all three children are standing all these three corners, right? I hope you understand. Now in the further it is saying that the children will make exactly n minus 1 moves. How many moves? N minus 1 means total moves. If it is n is equal to 3, means total n minus 1 equal to 2 moves. He can do 2 moves according to the following rules. To reach the room n minus 1, n minus 1 means target is, this is the corner where children have to reach there. Okay, means it is saying the children will make exactly how many moves? 2 moves, right? In this grid I'm talking about, according to the following rules, right? To reach the room, this room, right, that we have marked, the last room. Okay, so very first, the starting children that we have at 0 0, from 0 0 must move from their current room Ij to one of their room I plus 1 j plus 1 or I plus 1 j, right? Means it is saying I plus 1 is what? Let's suppose if this is your I, let's suppose move it like this. Okay, I, or this is your j. Okay, so if this is I plus 1, okay, so can we say that I plus 1 is this one, this grid? Okay, and j plus 1 is, let's suppose if it is j, it will come in this direction. Okay, so if I plus 1 and j plus 1 means we are not talking about this one. Okay, means which direction we are talking about? We are talking about this point, I plus 1 j plus 1. Okay, this one, both is 1 comma 1. Okay, and then we have I plus 1 and j, means he can go to, let's suppose, this direction. If it's I and it is j, we have taken I like this. Okay, if this is I and j we have taken, we can say, let's suppose he can go this direction, 1 and j, sorry, we can say I plus 1 can take, this position we can take, and this position we can take. Okay, you can take any position, you can think either this position you're talking about or this position. Okay, so and this position, either this position, this position, this position, all three directions he can go. Understand? Means let's suppose a person is there, he can go this direction, means each cell only three direction he can go, right? Similarly for this one, he can go this direction, right? Let's suppose if it is 0 and minus 1, means we are talking about this position. How he can go back, 1 second, just let me little do cleaning, we can understand. Okay, okay, now understand, we are talking about another kid, right? Another children that is at 0 and minus 1, we are talking about these children, right? Where he can go, he can go one of the room I plus 1 j minus 1, means if j minus, if it is this position, j minus 1 is this position and I plus 1 is this position, so it is talking about this position. Okay, then I plus 1 and j, so this position he is talking about this position, this is this position, this is I plus 1, this position, j plus 1. Okay, so he is talking he can go this direction and this direction. Okay, as we can see right here. Similarly, we have third children that he can go j minus I minus 1 j minus 1, is this position he can go, this position he can go, this position, like that he can go in the target rooms. Okay, I hope you understand clearly, it's not tough, right, to understand this type of problem. Okay, so what further it is saying that when a children enters a room, right, when a children enters in a room, they will collect all the fruits here. Okay, when a children enters in the room, they will collect all the fruits here. If the, let's suppose the children is going to this room from here, let's suppose he's itself here, there will be some fruits is there, so he is started collecting. He was here because this is for his room, right? So each children have initial stage at this position, this position, this position, means all the corner rooms they have, so they have entered in the room and they have started collecting the fruits. Similarly, if he reach to the next rooms, right, he will start going there and he start collecting the fruits. Okay, this is the sentence saying, if two or more children enters the same room, let's suppose somebody running from here and somebody also running from here, both are meeting here, right? Or three of them are meeting here, all of three is meeting here, right? Then if two or more enters the same room, right, means this room, we are talking about this room, 1 1, only one children will collect the fruit. The probability is that this person will change, these children, let's say C1, C2 and C3, three children are there, okay, C1, C2 and C3. Either C1 will collect all the fruits, C2 will collect fruit, or C3, no one knows. The probability chances are very less that anyone can get it or not, right? Means there is only position that 1 by third person, means out of the three only one person will get the what fruit, and the room will be empty after leave. So once they leave this room, right, they, the room will be empty because the fruits that had been collected there is collected by the children, right, that has been kept was collected by the children, right? So you will say what is the goal our have, right? So our goal is saying we have to return the maximum number of fruits, right, the children can collect from the game, right, dozen game, okay. So fruits we have given and we can represent like this. So initially, as you can see, the childrens are at the corner and they has to reach here. So they are moving right and collecting all the fruits, and they have to reach to the corner also, right? The goal is to reach the last corner, n minus 1, n minus 1, right? N minus 1 into n minus 1. We can say the last one, last grid. And they have also to collect whenever he enters in the room, right? To reach the goal, they have to also collect the fruits. It means we have to return the maximum number of fruits the children can collect from the dozen. So directly or indirectly, if you understand, very first we have to find the number of fruits that maximum our children can collect, okay. So how we are going to find that is the our goal. So let's see. So very first what it is saying that children first start moving from 0 0 to 1 1 to 2 3 3. So he reached there. Then children 2 starts with 0 0 3 0 0 1 1 1 1 2 2 2 3 like that. So all are reaching to 3 3, okay. So if in the total, because 0 0 reaching to this position, then this position and this position, okay, means if you observe, these childrens are the childrens are not going to the one room, right, they are going in the different rooms, right, as you can see, and they are collecting. So if the cell is different, right, we can get the value. If he enter a room that is already has been collected, he will get the zero value, like that. In total, if we'll do the sum, right, so these children, the question is saying that maximum number of fruits the children can collect from the dozen. So total, how many they are collecting, right? So at each position, if you see how many they are collecting from here is starting. So 4 position here, 4 position here, and 4 position here, means 16 times. So if you count here 1 2 3 4 5 6 7 8 9 10, it is coming only 10 times, right? Why? Because rest of the thing is 0. Where it is 0, here it will be 0. Because let's suppose very first he is reaching here, right? It means he can collect this one. The rest of the two will not collect. Means total is 9. Total is how many? 9. 3 3 3 3 3. Understand? 3 3 6 3 9. But out of these 3 we will get only one times, right? Means only 3 3 will get one value at a time, but rest of this will become 0 0. That is why from here it is saying that it is coming 1, right? It is coming 1 here, and the last element is coming is because it is already become what? 0. 1, it is connected, right? It's already collected. So total, if you think, total is how many cells are there? 9 cells plus one of these cells, the last cell, okay. Let's understand how to implement this type of question, right? So can we say that let's suppose, can we say that how many we have given? N cross n grids we have given, means total, if there is 4 corner is here, means 4 is this side also, so total become what? 16, right? So total 16 room we have in this grid, in this dozen, right? So each room contains some fruits, right? As you can see, these are the fruits we have given, right? And there are how many children are? 3 children are there. Let's suppose children A is here, children B is here, and children C is here, right? Each contains, let's suppose children A contains, children A starts at top corner, right? Where? Top corner. That is at where? Room 00. For B, we can take children B starts at this position, or we can say children B at this position. Means 0, let's suppose here itself, B. Means 0 and minus 1 we can take, right? Let's take this one. Okay. Means the top right corner. So this is about top right corner. Okay. So children C will take at the bottom left corner. This one. Okay. See, n minus 1 and 0 we can say that. And where we have to reach? N minus 1, n minus 1 we have to reach. That is clear? Means here we have to reach. So all the 3 children that we have A, B and C, right? All 3 children must reach to the bottom right corner here. In how many steps? N minus 1 steps only. No need to move, collect all the fruits, right? They have to take only one n minus 1 steps, not more than n minus 1 step. Okay, means let's suppose there is n equal to 4, right? Means a children A, B or C can maximum he can go 3 steps, maximum 3 steps he has to who has to take, and he has to reach to the where? At the right bottom right corner here, n minus 1, n minus 1. So each child collects the fruit as they move into the room. Whenever he starts from here itself, he will collect some fruit, then he will collect from fruit. Like that he will go and he will reach there, right? And he will collect the fruits. Okay, as soon as he reaches. So if 2 children enter the same room, let's suppose he is also coming here, or he can also, let's suppose all the children are coming in a room, right? Give me 1 second. Let's suppose all the children are coming. Let's suppose he is coming from here, then here, and he is here. But he starts from here, right? Like this, he reaches here. He starts with this and he reaches here. Whenever all these children reaches to here, right? Means if 2 or more children enters the same room, only one of them collects the fruits, right? So the value of 1, let's suppose either A will pick, B will pick, or C will pick, but only one can pick at a time. Okay. Rest of the thing, if let's suppose A is collecting, he will get the value. For the rest of thing, for 0 0. If one is not collecting, rest of the thing what? Like this. Or either B is, let's suppose C is collecting, for them it is 0 0. Means if 2 or more children enters the same room, only one of them collect the fruits, right? And the room becomes empty once they are collected. So rest of the thing become 0 0 0 0 0 0. Okay, so this is the thing we have given. Let's understand the movement rule, right? Very first, a child start at A, let's suppose at 0 0, right? So each child has fixed set of directions they are allowed to move, right? Let's suppose for a children A that is at A, right? Children A is at 0 0, the very first room, right? He can move where? In the right direction, right? In the right direction, if this is, let's suppose, if this is I, right? And this is your J, right? So can we say if this is your J and this is your I that we have talked, right? So either he can go where? I to I plus 1. Let's suppose for children A, he can go where? I and then I plus 1. It is saying, means he can go this direction, right? Means he can reach to this direction here, right? And either he can go to the down here. So for the, this is your right direction, and for the down we can say which direction? We can say I plus 1 and J. Can we say that? Means this position, correct? And there is another position is diagonal. He can reach to here, means he can go to I plus 1 and J plus 1. So this is your diagonal. Can we say that? How many positions we have? 3 positions we have. So he can go right, down and diagonal. Can we say that? Similarly, if we'll talk about for child B, let's suppose child B as this position. Okay, so for child B, he starts at where? At the top right corner. That is what he start at 0, and we can say n minus 1, right? Yes, he can start at here. So he can move which direction? He can move to very first down, right? Where? At I plus 1 and j. So this is I plus 1 and j. He can reach to here. I hope you understand, right? Then he can go to down left. So can we say that he can go to this side, right? Or we can say down left. We can take this one also, right? And this one. This is your down right, and this is your down left. Okay. So for down, let's suppose if we say down left, can we say I plus 1 will be there and j minus 1 will be there, right? And down right for we will say that is I plus 1 and sorry and j plus 1. Can we say that? Give me 1 second. Like this. Okay. Similarly, if we'll talk about who is at here, right? C. He is at here. We'll say n minus. He is at n minus 1 and 0. So what are the positions he can move? Right. Very first he can go to right direction. Right. For he, what is the right direction? Is right means he can go I comma j plus 1. Then we have the we can go to upright here, right? Or you can say this one he can also go, right? We can say upright. Let's suppose for his first he is going means I minus 1 and j plus 1 upright, right? Then there is a third position, then he can go here, right? What you call we can say this down right, right? Down right I plus 1 and then j plus 1. Can we say that? So all these positions he can move. I hope you understand this clearly. So let's suppose very simple, you don't need to do this one. Okay, very first let's suppose if you have 1 2 3 4 5 6, this is 7, this would be 7. Let's suppose I'll keep it as a 8 7 9 10 11 12 13 14 15. Let's suppose this will put as a 16 for example. Okay, means total how many we have? N equal to 4 we have given. So each children can take how many steps? 3 steps he can take, because n minus 1, right? N minus 1 is he can take maximum 3 steps. So all these children A, B or C can take how many steps? 3 steps he can take, right? To reach where? The 3 at this position, correct? Can we say that? So child can explore each children can explore the path, right? So one possible route that gives the maximum fruit. So he has to think, like let's suppose one is going to start from here. He should go here, here or here. Just think, for him this is a good place, right? Because he can get maximum 4, maximum 6 he can get, right? If he go to this direction, right side, he will get what? 2 fruits. If he going to the down, he get to 5 fruits. What if he go to the diagonal, he will get how many fruits? 6 fruit he can go, right? So can we say for A, who is at the top left, right, starts at 0 0, he can start at 0 0 0 0 and then he should go 1 1. Can we say that? We can say that. Then from 1 1, where he should go? He should go this direction or this direction. So as you can see, there is a maximum fruits is there. So he should go this direction. We'll say 2 2. Now he has done already one step here, one step here. 2 steps is done. He has left one step to reach to there. So he can directly take this step. So he will come to where? 3 comma. So 3 step is done. Step 1 was there, step 2 was there, and step 3 is there. I hope you understand. Similarly, we'll do for all the other childrens. There is one interesting concept here. Let me tell you what. Okay, now think that the A has completed these steps. Okay, now think about who children B. You understand this, right? If you have any doubt, let me know in the comment section, guys. Let's suppose about the B. So B starts at where? 0, 3 at this position. So if B will start, let's suppose at he is at 0 and 3. Very first, he can go this direction, or this direction, right? Let's suppose he's choosing what? 1, 2, right? Let's suppose he's choosing 1 and 2. Can we say that? So for 1, 2, it means this direction, means this room, right? Similarly, he can take what? This direction he can take, this direction he can take, right? All this direction he can take. Let's suppose from 1, 2, he's choosing 2, 1, right? And then he will reach to 3, 0. Just for understanding, okay? So the fruit that he is collecting, right? Let's suppose is 4, 8, 10 and 13. Can we say that? So total he is getting, let's suppose 35. Okay. So similarly, if you do the sum of these fruits, how many he will get? 1, 1 plus, it was 6 plus 11 plus 16. You can see there, right? Total 34. He is going to 34. He is getting 35. Okay. So now what we need to see, if we see A and B, right? Here, no overlapping happened for the B. There is no overlapping happened with children A, right? No overlapping. No overlapping happens with child A. Can we say? We can say that. But now think about, let me clean this one. Okay. Now think about children, other children. I'll take this one. Okay. Children C. So children C start at here, 3, 0. Okay. So if you start with the 3, 0, he can go what? 2, 1. Then he can go to 1, 2. And then he can go to 0, 3. Just for understanding, right? So if he starts at 3, 0 and he go like this, right? But wait, what he collected the fruit? Very first, 13 plus 10 plus 8 plus 4 is 35, right? But wait, B, as you can see, child B already passed through this exact room, right? So this is what? Overlap. So they have overlap. So we count fruit only once. Okay. What we will do? We will count the fruit only once. We cannot use this again. Okay. So to avoid the duplicate, what we need to do? Let's understand again. Okay. We need a plan. So the children can collect maximum fruits without overlapping, or at least minimize the overlap. Okay. So can we say there is an optimal path? Optimal path. What is an optimal path? Okay. Let's suppose children A we have, right? He starts at 0, 0, right? Then he will go to 1, 1. Then he will go to, after 1, 1, it is go to 2, 2, right? And he is to 3, 3. Can we say that? He is going like this. Okay. So what he will get? What he will get here? He will get 1 plus 6 plus 11 plus 16 equal to 34, right? Very first started where? At 0, 0. He reached from here to here 6, then 11, and then it is 16. Okay. So it is to 16. Okay. Because as per this is 1 and this is 16. It's a mistake. Okay. So this is 16. He will reach to here. Okay. Now think about the another one that we have, B. So can we say B start at where? 0, 3, right? 0, 3. Then it will go to 1, 3. Then it will go to 2, 3. And then it will go to 3, 3. Just for understanding, okay? So how many fruits he will get, right? He will get what? 4 itself, then 7 plus 12 plus the last one is 0, because that has been already utilized, right, by A. This has been already utilized. 16 has been used by who? A, correct? Now try to understand the C, okay? C starts at 3, 0, right? So can we say 3, 0, then it will go to 3, 1, then it will go to 3, 2, and then it will go to 3, 3, correct? Now do the sum. How C gets, the children C gets what? 13 plus 14 plus 15 plus 0. It is becoming 42, right? So total coming 42. If you add them all, right? Let's suppose if it is 42 here, so total is what? 42 plus what we have? 23 and then 34. And we say that if we'll do the sum, let me do the sum. Let me pause it. 4, 3, and 2. 5 and 4, 9. And 3 to 5, 4 is 9. Okay, so total coming 99. So it is close to max, we can say that, right? So, but the optimal solution that we have, right, is collecting 100, right? Just for understanding, it was about 100, right? I think I saw that 100. It is coming 100, collecting 100. Okay, so maybe some mistake in there, so we will check later. Okay, for now you just think that this is the optimal way to avoid the duplicates and we can find the things. Okay, means the concept. Okay, means we have to also avoid the duplicates, or we can say without overlapping, or we can say we can minimize the overlapping, right? At least if we are not avoiding, we can minimize the overlapping, so we can find the optimal answer, optimal maximum what you call fruits. Okay, so what should be our strategy? Just think, our strategy should be, we should add the main diagonal path for A, right? A path has always fruit I like that, I like that. Okay, so then we'll run the DP from the top right B. Okay, and it will find the best path for n-1 n-1. Okay, once these are done for A and B, means we want to add the main diagonal path for this A complete directly from 0, 0 to where? At 1 at n-1 n-1, we can say that. Okay, means A has always the path I, right? Fruits at I, fruits at I. Then for top right corner that we have, right, we will obviously, if this is grid, we are doing the multiple calculations, we should use DP. If the size become more, right, we should use DP. Recalculation should be avoided, right? So for B that runs at top right corner here, right, the best path we have to find for n-1 n-1 for this. So these two, when done, then just we have to transpose the grid, right, from bottom left, and we'll to the right one, right? It means how we should write the code. We should write the code first. That will start at where? At children A path, like this. It will fruit at I 0, 0, fruit at 1, 1, fruit at 2, 2, fruit at 3, 3, like that. It always have a one path. Okay, for children B, right, which is at the top right corner here, right, then DP should run from where? At here, and it should find the best path for n-1 n-1. Whether he is coming this way, this way, this way, he could find the best path, so he can find the maximum fruits for the B children, right? Children B. Then transpose the grid. Just you transpose this grid, right? So bottom left corner that we have here, right? Bottom left that is C is here, right? It will look like a top corner here, top left. If you do the transpose, just you move it, right? Means this will go to this position. 4 and 13 will be, what will happen? It will replace, right? Can we say that? If the transpose will happen, means this column will become the first row. Means the first column will become the first row, right? Like that it will become, means that we are going to transpose the grid. So the bottom left C, right, we can become the top right corner. Understand? If you have any doubt, let me know in the comment. Okay, so again we'll do the same thing to DP, run the DP to simulate the things, right? And we'll find for the C also. All three children will collect as many fruits as possible with the minimum overlap. Okay, I hope you understands. So what is the our intuition, right? So we have given this n cross n grid we have given, and we have given three childrens we have given, right? That we have seen this 0 0, this top left corner, we can say top right corner, and the bottom left corner, right? All three children must reach to the where? At the bottom right corner, n minus 1 in exactly n minus 1 step, right? And there are some specific movement rules that we have seen, and each children collects the fruit from their rooms, right? And whenever they visit the room, right? However, if two children visit the same cell, right, the fruits are collected by only one, right? Only once, we can say. Our goal is to maximize the total fruits collected by all the children. Okay, so what is the intuition we have here? So very first, the diagonal cells are always visited by A, right? So we'll keep the children A moves like 0 0, 1 1, 2 2, 3 3, like that. It will keep moving till the n minus 1 grids, right? So diagonal will be for child A. Okay, it is a it is a kind of guarantee path, right? So those fruits can be collected by starting from A 0 0, right? So added directly to the start. So we can fix this path and avoid checking overlapping here, because A already taken this path, right? Now focus on B and C. So the remaining children B and C must always reach to the path n minus 1, right? Using their movement rules. So B moves down and diagonal and the top right, and C move where? The right diagonal and bottom up, bottom left, we can say. Okay, so now the problem becomes what? Find two non-overlapping path as much as possible for B and C, right? From their respective corner, from here and here. Understand, right? Means it is very simple, right? Because children B and children C both have to reach where? n minus 1, right? And we know their rules, how they moves, right? He can move here, 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 like that he can move, right? But the real problem is what? It is different from that we have given. That is, we have to find non-overlapping paths as much as possible for what? For B and C from their respective corner, and they have to reach to where? n minus 1, this position. So as they collect the maximum fruit without interfering, or you can say overlapping with A, they should not overlap this direction. You have it, means what I'm trying to say, what is the problem is there, right? So we know that A path is already fixed, this path. Who will go? A will go, right? The real problem is there. We have to find two non-overlapping path for who? For B, and for who? C. And both have to reach where? At here, at this position. Everyone should have to come here, right? A has came, but you also have to see that without overlapping these fields, right? Means this one, and this one, by B and C, they have to reach here, so that they can find what? Maximum fruit. Understand? He has to find the path. Either he can go like this, and he can reach. He can find this, and this, he can reach. Number of steps is different thing that he has to consider how he will go, but they should not interface what you call interfering, or you can say overlap to a diagonal. Okay, so this is the intuition we have. So very first, if you talk about the high level things, how we are going to implement, right? Very first, start collecting the diagonal. Since children A always takes what? Path I and I. As you can see here, right? It is taking all the path. So for we can take, we'll start I equal to 0 and we'll go to n till n. Means I should be less than n, I plus plus, I'm saying, okay? So if we'll take answer, we'll just answer plus, we'll say fruits at where? I and I. This we will store for fruits at I and I. By who? For children A. So children A, right? Very first, we have to collect the diagonal fruits. For who? This is a diagonal fruit. Diagonal fruits. So we have to collect all the diagonal fruits. Collect all the diagonal fruits by A. How? Because this path is, since children A always take the path, diagonal path, and that diagonal path is where? At I and I. If we have to collect, we have to make a for loop from 0 to n, and for all the path that we have at I and I, that we will store at answer. So this will avoid the complexity of managing overlap with A. I hope you understand, right? Now think about, let me clear it. Now think about who? Uh, Dynamic programming, DP, for child B. Guys, we are using DP, right? Because we don't need to recompute again, right? So if we'll use the DP for B, means we want to go from where? 0 to n minus 1. He's here, right? And he has to reach here at this position. So can we say that he has to go from 0 n minus 1 to n minus 1, sorry, and n minus 1. This position, this room to this room, this cell to this cell. Can we say that? So, and movement for B, we have to use in 1D array, right? We'll use 1D DP array, okay? And we'll store the movement of B, we can say. So movement of B we will use where? At 1D DP array, right? Just you need to do what? DP at array, and you have to define the size. I hope you understand these things. Okay, I'm considering that you understanding. If you have any doubt, let me know in the comment section. So for at every steps that B will do, right? Either he will go down, down he will go to where? I plus 1 and j, right? If he has to go to the down left, I plus 1 and j minus 1, right? If he has to go to right, we can say I plus 1 j plus 1. Let's suppose for this guy, for B, right? So what we need to do, we have to store the previous j and current j. Means maximum, what is the previous j? We have at previous, let's suppose j, and we'll say previous j is the maximum fruit collected to reach where? I minus 1 and j. So I minus 1 and j is the previous at j we will store, right? Because this is the maximum fruit. This is the maximum fruit which is collected to reach where? At I minus 1 and j. Understand? Because B can go where? B can go 3 directions. I plus 1 and j, right? Or he can go I plus 1 and j minus 1. And he can go at I plus 1 and j plus 1. All these 3 directions he can go, right? That we have seen. I plus 1, I plus 1, j minus 1, I plus 1, j plus 1. Okay, so all these 3 directions he can go. So we will take a previous at j. This will be our maximum fruit that we can reach to where? I minus 1 j. We'll take a current j and we'll store what? The max fruit for current row, right? This is the maximum fruit collected to its reached I minus 1 j, and this will take what? Current at I, maximum fruit for current row. So why we will use? Because if we'll do the current at j, just we need to do what? Max between previous j, and there will be a what you call previous j minus 1 we can take. Previous, we'll take this previous j minus 1, right? And these two things will take, and okay, so this is the max we have to take between these, which one is coming the max, right? And we can take a value previous at I minus 1 and fruit I plus j. Okay, so one we can take what? This is the one thing you have to do, one parameter we have to take in the max. Another we will take previous at j plus 1, and then we'll take plus fruits at I plus I and j, sorry, I and j, yes, like this. Let's understand what. So after n minus 1 step, right, and previous I minus 1 is what? It will contain the maximum fruit for path to reach to n minus 1 and n minus 1 this path. Okay, when you will understand the code, when we go to the code, you will understand. In the third step, I told you, for once we do this for the B, right, we'll do the same thing for the C, but we need to do what? Transpose. Remember, we have to do the transpose. So transpose of grid, if we'll do the same thing, just you need to flip the what? This fruit matrix. So this will go at this position, means this column will become this row. This is the happening, and rest of the thing will happen for all of this grid, right? Means if you'll talk, let me clean it so you will understand. So very first I was talking about, so this will go where? In this direction, because we are going what? We will do in for C, right? Where is C? For we'll do what? Transpose of grid we will do, right? Means we will flip the row and columns. So for that you will take for loop. You will start I equal to 0 to, you will go to the n, and similarly we'll go j equal to 0, you will go to the j should be less than n, right? And j plus plus. We'll keep doing that. You just need to do what? Swap, right? How will do? So you will take fruits at ij, and fruits at ji, like that you will do, right? And you keep doing that, you will transpose it. Now just you need to do what? In the next step, you will add all the results, and that's our job. Let's understand the code. So very first, what you need to do for A, this is your first step where children A will go diagonally and will store the result, right? Then we'll create a supplier, right? This is a DP function in Java 8, right? We'll create a supplier, we'll pass this value, right? And we'll collect the using the previous and current value, we'll calculate it right here, right? And you will go for all the loop as we have discussed, right? You will go to the n minus 1, 1j and j plus 1, and you will find the best value for base from the previous j, and you will calculate these two best you will find from the previous I minus 1 and previous j plus 1, and you will calculate the best current j, right, for all the row, you can say, and you will swap the value. Okay, and then you will return the previous at n minus 1, right? Again you will take the, for the C you need to do what? You need to transpose the grid, right? Or you will go for I and j. I should be go to 0 to n, you can say, or it will go to n minus I minus I should be, j should be less than n, I, and you just do the swapping here, right? So all the moment for children C become from bottom left identical to bottom B, right? As we have seen, right? Means bottom left becomes the identical to bottom B movement on the right, because we are doing this swapping, right? And that will happen. So that's all I have, And if you any doubt, let me know in the comment section. I'll do the dry run this code later today. I also have not done yesterday problem, but I will do in this week. Okay, let me know if you need the dry run or not, right? I have not got the information in the study video, so I have not prioritized that, but let me know in the comment section that you want or not. Thank you guys, thank you for watching this video. I'll see you in the next one.